Welcome back. This is the beginning of week 3. We'll be covering lists and logicals. Okay, so the destination that we're headed towards in this lecture is we'll be eventually using logical operations to get the things that we want from the data structures that we have. So we'll go through these data structures, we'll create lists, we'll create data frames, and then we'll be practicing using logical operators to get stuff from those data structures. Okay, so if you remember at the end of the last screencast, we created a data frame called df1 out of 3 short vectors. We did that with the data frame function that bound the vectors together where each vector became a column of the data frame. And then when we ran type of on that data frame, the type of returned was list and the class was data frame. So what that's telling us is that data frames are a particular class of list. So they're just a list with some restrictions on them or with some special behavior. But we didn't go over what a list is. So let's talk about what lists actually are. So lists are a general form of vector in which the various elements need not be of the same type. So if you remember, the thing about vectors was that everything in it had to be of the same atomic type, whether that was character or numeric. Everything in a vector needed to be the same type. Lists are not that way. A list can be a collection of all different types of data, and they don't even need to be the same length. You can have a list with one element that is a character vector of length 4, and you can have the next element be a numeric vector of length 4,000. It doesn't matter. You can throw them together in the same list. So you can start to see that this is a very flexible data structure. Another way to put this is an R list is an object consisting of an ordered collection of objects known as its components. So a list is an object, but within that object you can have a bunch of other objects. It just is a way of collecting them all together in one structure. Okay, so let's go make a list. Okay, here is our logicals and lists script. And before we make our list, I'm just going to mention that I use the equal sign and the assignment, what's called the assignment operator, interchangeably. They do the same thing. There is esoteria that you are free to look up on the internet for the true difference between them. But especially for this class, you really don't need to worry about which one you're using. Both are fine. All right, so let's make a list of some of my favorite things. So this list I'm calling my faves, and we use the list function here to initiate a list. And then to create the components of the list, you can name them. And if you do, the name goes on the left-hand side. So I'm naming the sea mammal components this, and then I'm creating a character vector of my favorite sea mammals. We have a numbers vector, a favorite dive spots vector, and a favorite R datasets vector. And I will show you what those are in a second. So if we create this list and then inspect it, you can see it's a pretty big list. And the first element here is the sea mammals, and then numbers, dive spots, and then the last 2 components or elements of the list are these data sets. If you're not familiar with the data sets that are built into R, you can check out library help quote data sets, and that'll bring up all of the names of the data sets that are built into R, and you're free to research those on your own. The 2 that I included in my list of favorites are the rivers data set. So all you have to do is type rivers, and that'll bring that up. It's just a vector of river lengths in miles of rivers in North America. And then the Nile data set is a time series. And you can look up the documentation for these data sets on your own if you're curious. So what is the structure of the My Faves list? See, it's a list of 4. So you can think of that as a list of length 4. And the 4 elements are the sea mammals, numbers, dive spots, and data sets. And then within those elements, it tells you more about the structure. So we see we have a character vector of 1 to 3, numeric vector that is just 1 element long, Dive spots is another character vector, and then the R datasets is itself a list of 2. So hopefully that illustrates that you can really have a tremendous amount of flexibility in your lists. It's fine to have lists of lists. You can have a list of data frames. You can have a list of matrices. The list is an extremely flexible data structure, and it gets returned a lot by a lot of different R functions that are pretty common, so it's good to be familiar with them and how to manipulate them. So we've made our list, and as we've said before, a data frame is just a special class of list, so we should be able to use this as.dataframe function to coerce the myfaves list into the data frame class. So let's try it. And it's giving us an error. It's saying the arguments imply differing number of rows. So why are we getting this error? Well, there's some restrictions placed on data frames, so let's go over those. So those restrictions are that the components of a data frame must be vectors, so already our list didn't qualify because we had a list in our list. And each vector has to be the same length. So in other words, there needs to be the same number of rows in each of the columns, since each vector becomes one of our columns. You can turn any list that meets these restrictions into a data frame with the as.dataframe function, but ours did not meet those restrictions. So we've created some data frames from scratch, but obviously the easiest way to create a data frame is just to bring it in directly from tabular data that you have outside of R, like in a CSV or an Excel file. So the data frame that we're going to be working with the most is this Cod Parasite data set. So we'll be using this Cod Parasite data to learn about logical operators. And I'm not going to go over each one of these individually. You can look at the slide later if you want. I just want you to start thinking about logical operators as questions, which have true or false answers. For example, is it equal to blank, true or false? Is it greater than or less than or equal to blank, true or false? Is it not this, true or false? Or is this an element of this, true or false? And so on. So the more we can start thinking of logical operators as asking questions of our data, I think the better off we are. These will make much more sense once we switch over to R, but I just want to zoom out for a second to let you know where we're going and why we're going there. We're using these logical operators to, again, ask questions of our vectors and our data frames to get things from them that meet our desired conditions, like, for example, subsetting your data, or how many observations there are after a certain year, etc. This is a way to get there. So our objectives with this lesson, once we head over to R, is that we want to be able to make lists and data frames using the list and data frame functions. We've already seen the list one. We'll go over the data frame one. And we want to use logical operators on simple vectors, and then use logical operators and the bracket function to extract or subset the things that we want from vectors and data frames. All right, here we are back in our R script. We remember we weren't able to make a data frame out of the myfaves list because the objects in it weren't of the same length, but we should be able to make one out of this Cod data set. So you should be able to download this CSV from the course repo. You can either completely re-download the entire repository and work from there, or you can just save the CSV individually to the repo that you were using in the scripting video. All right, so let's save our Cod Parasite CSV as an object called Cod, and we will inspect the structure of that. We see it's a data frame, and again, the key component here is that it's 11 variables, 11 columns, all of the same length, so they all have 1,254 observations. Those are the names of the columns. They happen to all be integers. That's just the way that this data is. So we've made that data frame. We're going to put that on a shelf for a second, and we'll go over the basics of logical operators before we get to using them on a data frame itself. We're just going to start with using logical operators on simple vectors or short vectors, and then we'll build up to using them to index long vectors, and then finally indexing data frames. So logical operators, let's start with the first one, which asks, is X equal to 5. And the first thing that we have to do is actually save a variable called x. So that happens at the top of the script. We'll run these 2 lines. They do the same thing. And now we're going to ask R, is x exactly equal to 5? Is this true or false? And it's true. Is x less than 6? So what we're asking is x, which is the value of 5, less than 6? Should be true. Is it greater than 6? That should be false. Let's move on to a slightly more complex vector. So we're going to create the vector y with the concatenate function. Y is just the odd numbers 3, 5, 7, 9. And now when we ask if y is less than or equal to 5, it's going to go element by element and tell you whether each element of y is less than or equal to 5, true or false. So what we're going to get back when we run this line 50 is a logical vector that will be equal to the length of the vector y, because it needs to tell us for each element of y whether this condition is true or false. So we see that it's true for the first element of y, 3 is less than or equal to 5. It's true for the second element of y, 5 is less than or equal to 5, and then it's false for those final 2 elements of y. The next one asks, is y not equal to 5? So that's going to say which elements of y are not equal to 5. So that's going to give us true, 3 is not equal to 5, false, 5 is equal to 5. Then true, 7 is not equal to 5, and true, 9 is not equal to 5. You can add conditions on with this and symbol, the ampersand. So we're asking which elements of y are not equal to 5 and are greater than 7. So we see that it's false. 3 is not greater than 7. So that second half of the conditional is not met, so we're going to get a false. And the only one that's true here is the last one. 9 is not equal to 5, and it's also greater than 7. The difference between lines 52 and 53 is we're changing that and logical operator to an or logical operator. So now we're asking which elements of y are not equal to 5 or they're greater than 7. So that if you can pause this video and predict what you think should change from the last line to this line, that would be a good exercise. We'll run this, and we see that the conditions have changed. 3 now returns true because 3 is not equal to 5. It's not greater than 7, but the condition was or. So is it not equal to 5, or is it greater than 7? 3 meets those conditions, and you can go through the vector and work this out on your own. I encourage you to play around with this stuff if it's not making sense. It will start to make sense, especially as you write your own statements that are more in line with the way that you typically ask questions. Okay, and then this final one is asking element by element, is y found inside this vector? So what this is going to do is say, is the first element of y, 3, found within the vector 5, 6, 7, and 8. So the first thing returned should be a false, right? Because 3 is not found within that vector. The second thing returned should be a true because 5 is found within this vector. And then it'll go on like that. So why don't you pause and predict on your own what this will return when we run it. So I predict this will return a false, true, true, false. And that's what we get. So again, if that didn't make sense, I encourage you to go back and create your own conditions and your own statements. Play around with this, create different vectors, compare different vectors until it starts to make sense to you. The next part of the video is really not going to make any sense. So it's important that these fundamental operators are clear in your mind and you're clear about what they're asking and doing. So hopefully that's making sense. I'm going to expand this view so that you have a little bit better view from here on out. If what we're interested in is not a logical vector, but the elements of the object itself, then we have to move that logical condition statement, or that logical operation, within this bracket function, because again, that's what is going to actually extract the thing that we want from the object. So here we're saying from y, extract all of the elements that are not equal to 5. So we should just get back 3, 7, and 9, and that's what happens. Okay, so I've reset my console here. We're now going to be using logical operators and brackets to index and subset a more complex vector. We're going to be using it on an actual piece of data here. So we'll use the rivers vector. So again, if we run this, we see the entire rivers data set is just a numerical vector. There's 141 elements to it, and you can find that out with length of rivers. So it's 141 elements long. And let's say we want to find out how many of the rivers in this data set are longer than 200 miles. So I'm going to say or create a logical vector with this conditional statement, which of the rivers are greater than 200, and I'm going to save that to x. So if we go look at x, we see that it's a logical vector and it's telling us exactly whether that element of rivers is true that it's greater than 200 or false that it's greater than 200. And we see that there's only one river that's less than 200 miles long because there's only one false there. We could just eyeball that here. If we really wanted to find out, then you would run sum on that logical vector, and since trues are equal to 1 in R and falses are equal to 0, we would see that 140 of those rivers are greater than 200. Okay, but again, to get back the actual values of the vector that you are subsetting, we have to quote unquote index it. So I keep saying the word index. All I mean by that is we're creating a logical index of the vector itself. So that's what we just did in creating x. We can use x as an index on the vector itself to get back the values from rivers that are greater than 200. So I do that here in the second line. Let's actually run that first. So I'm saying let's subset rivers by the vector, the logical vector x, and save it to y2. So y2 is now all of the rivers that meet this condition. So we should get everything except that one river, which wasn't greater than 200. So those are, now we have those actual values saved to y2. If we look at the length of y2, we see that it's 140 instead of 141 because it dropped that river that didn't meet the condition. So another way to do this is to just, again, put that conditional statement directly in the brackets like we did up here, and that would get us back the same thing. I've saved it to y here. We do length of y, it should also be 140. And if we want to be really sure that those two lines of code, lines 70 and 71, did the same thing, we can run this function identical on the two objects. So it's just saying, what this function is asking is, are the objects y and y2 identical? And it also returns a logical, and we see that it's true. Okay, so there's some additional code here. You can go through it on your own. Again, I encourage you to just play around with these things to get comfortable with it. Okay, so way back when we created that Cod dataset, it's still in our workspace as the object Cod. So now we're finally getting to the point where we're going to use logicals to index and subset entire data frames and not just vectors. So this is what we were building up to. We want to be able to use these statements to actually ask questions about our data. So here's where we're starting to do that. So the first thing that we're going to do is create a vector. I'm calling it cell. It's just short for selection. And we're going to create a logical vector where all of the elements in the column year from the Cod data frame are exactly equal to 1999. So if we go over to the console and inspect that vector, it's a logical. columns of data frames are just vectors. So we're really doing the exact same thing that we've been doing when we're only working with a single column of a data frame. So if we want to index the entire data frame, so in other words, we're not just getting back the parts of the vector that meet a condition, we're getting back all of the rows that correspond to the vector that meets the condition. We have to use this comma in our brackets, and that's because data frames are not one-dimensional, they're two-dimensional. So we index them by 2 dimensions, rows and columns. So let me run this and then I'll break it down a little bit more. So in plainer language, Cod2 is just all of the data from 1999 because we're asking it for all of the rows from the data frame Cod where there is a 1999 in the year column. So it might be helpful to view the data in a more tabular way. So if we view Cod, these are all the rows, these are the columns up the top. This is the year column. So Cod2 is now all of the rows where the year is equal to 1999. So as soon as we hit a different year in the year column, which I guess is longer than I was giving it credit for, as soon as we hit like 2000, anything different from 1999, it's not going in Cod2 because that condition is no longer met. And so the falses start in that logical vector, and anything that is false gets dropped from Cod2. So Cod2, so the only thing that's left in Cod2 are the rows that meet that condition, and those are the 1999 rows. So if we view Cod2, we should only see 1999s in that year column. And this is not a good way to verify that your condition worked as you intended it to. A better way to do that is, for example, to table Cod2 by year. And in that table, we see that there's only one category, and that year is 1999, and all 567 rows belong to that category. So our condition was a success. All right, let's work through one last subset. So let's say we want to subset all the Cod that are not of age 0. So first, let's see what ages are represented in the Cod data set. So we have 0 through 10. If we want to get rid of all of the rows where the entry in the age column is 0, we can do that with this line of code. And just like above, we're now saving it to the variable code Cod2. So this is going to overwrite the one that we made above. But one thing you should know about R is there's always more than one way to do something. So I'm going to have you work out a different way to do that same thing on your own. And then the rest of this script goes through a few more types of subsets of the data frame, and including linking different functions together with conditions. But you'll notice the syntax is always the same. We're asking for the condition over here because that's going to tell us which rows are returned. And then this blank after the comma really represents us asking for all of the columns back. So what we're saying with any conditional statement here when we're indexing a data frame is I want only the rows that meet this condition, but I want all of the columns back that correspond to those rows. Okay, so you can work through the rest of the script on your own, and I will see you in the next video.